Ruby. Please join me in welcoming our speaker, Hitoshi HASUMI.
Hi, hello. Oh, do you hear me? Okay. はい、はい、近づいて、はい。Hello. You're very lucky because you chose my talk. I think there's a lot of talks that are difficult today, right? You look tired. My talk is very easy. Be relaxed. There. So let's start. I still have one preparation. Wait a minute. Uh, 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 uh. Hello. The title of my talk is PicoRuby, Episode 4, The Rise of Microcontroller. Actually, this is the Episode 4, and former talks, Episode 2, Attack of the Rake, Episode 3, Revenge of the Standard In, and Extradition in Euroco. This year, a beginner's complete guide to microcontroller programming with Ruby. Be able to find in the internet. Please check it later. And episode 1 is hidden story. It's not still published yet. Let me introduce myself. My name is Hitoshi HASUMI. HASUMI is family name, and Hitoshi is first name, so you can call me just Hitoshi or Hasumi-san or Hasumi-kin is still okay. It's my internet name on GitHub and Twitter. I am the creator of PicoRuby, which I talk about today. And PRK firmware. PRK firmware is a keyboard firmware written in Ruby. Actually, this keyboard is run with Ruby now. And I am a committer of series IRB and Reliant. This year, end of this year, 10 days from now, Ruby 3.3 will be shipped with new IRB, which has been very improved one. So please take a look at the new IRB with Ruby 3.3. Actually, here's another IRB maintainer out there. She's also the maintainer. Please ask her, not me, about IRB. And I am the first prize winner of PicoRuby Award twice, and I was a final nominee of the Ruby Prize 2 years ago, I guess, because of PicoRuby. And can I ask something? If possible, please turn off your Bluetooth, because I'll show you a Bluetooth application on a demonstration. BLE channel, the number of BLE channel is, I think, 12. It will be very congested easily. So just turn off your Bluetooth during my talk. And let's begin. with the microcontroller programming with Ruby. Connect Raspberry Pi Pico and laptop while pressing the boot cell button. You'll find RPI, RP2 drive in File Manager. While pressing boot cell button and where? Oh. Connect. And download r2p2.uf2 file from GitHub or release github.com/PicoRuby/r2p2/releases. It's a executable files out there. Then just drop into RPI RP2 drive. So you can find a screen look like this. Let me try one. Yeah, here comes PicoRuby. This is the first screen. This is the hardest thing of my talk, is that every computing resource is in the Raspberry Pi Pico. This screen was created by the Raspberry Pi Pico, not my laptop. Is it okay? Then this looks like kind of Unix-like shell. So you can type some command like ls. There's no file. pwd. Oh, now I mean at home. ls things like bin. There's some executables. Maybe we can use date command. Yeah, epoch time, right? Like this. The Raspberry Pi Pico doesn't have battery to keep the current time over real-time clock. So every time you start the Raspberry Pi Pico, the time should be back to the epoch time. But you can persist the current time using battery if you want. And this also has IRB. Oh. Hello? Yeah. This means Ruby itself running on microcontroller. Furthermore, Ruby can be compiled into VM code on the fly. Do you happen to understand? This means very small footprint Ruby parser is running on the microcontroller, which I wrote. By the way, RP2 stands for Ruby on Raspberry Pi Pico, RRPP. So that's why I named it R2P2. I will move such kind of robot with Ruby in the future, but not for today. And this is today's outfit. 2 Raspberry Pi Pico W here, and character display module, this, and some sensor module, and the FTDI USB TTL serial converter cable. This is the setup for today. About Raspberry Pi Pico. There's two kinds of Raspberry Pi Pico, which has W and doesn't have W. W means wireless. It has a feature of BLE and Wi-Fi. Today I'll show you the BLE feature. Okay. This is the very beginning of the microcontroller programming, GPIO. Let me do it. GPIO call. That's correct. CYW43 is a wireless module. Oh, I should have require CYW43 and CYW and if I write GPIO.write 1, what's going to happen? Guess what's going to happen? Yeah, turn on the light. To turn off, GPIO write 0. Right? So you can do things like that. 3 times do sleep 1 GPIO write 1 sleep 1 GPIO write 0. What's going to happen? Obviously. Oh. Times. By the way, this is the multi-line IRB because I am IRB maintainer. 3 times do. Hue. But yet, this is kind of messy thing, right? You can incrementally try out the GPIO. How does it work? But every time you don't want write CYW something blah blah blah, right? So let's make a LED class look like this. Actually, let me use it. R2P2 has a text editor. Actually, Vim live LED RB. own method. How does own method look like? GPIO? What? What do you guess? If you want LED turn on, right? Right? What? One. Really? How about off? Oh, are you a co-pilot? And one more thing. Invert. If what should go? What should go? No. Just off. Please pray for me of working this. This is kind of VI editor. How can I save this file and exit the editor? How can I? Clone W Q. Great. IRB require LED to LED equal LED new LED on. Oh. Oh, yes. Right? And if I hit LED invert, it turns off. Oh, read. Oh. Please work. Yeah. Something's wrong. Don't mind. Let's go next. Yes. And GPIO is the most basic peripheral of microcontroller. These three peripherals are more, how can I say, practical ones, which are serial communication protocol, I2C and SPI and the UART. What we are doing of writing LED class. LED class means kind of device driver, right? LED class wraps GPIO class, which is the basic low-level function. So we can do the same thing. LED class looks like very, that was a piece of cake. But as we will see from now, wrapping I squared C and wrapping SPI is very valuable than much more valuable than LED class. This is very long to type for me, so I will do cheat. Where? No. Taiwan. To see new. Something goes wrong. Oh, it doesn't work today. Oh, I'm sorry. I mistake. This should be the one. Because ITC is this. Yes. These are just initialization procedures. Don't mind the details. Oh. My clipboard breaks. Oh. I'm ready. Oh. ドキドキする。See the camera. Something went wrong. Wait a minute. We have enough time. connection was loose. Just. I made a kind of mistake, but yeah. Let's go move on next. This is very long to type, right? Maybe because I made a mistake, so this should not work, Taiwan, but it's okay. It's okay. We will see the better one. Actually, this has already lcd.rb. So where is the slide? Slide. Huh? Okay. Hmm? LCD class looks like this. Not so complicated, right? But you can already familiar with reset method. I showed you just before. The usage of LCD class look like this. LCD new I2C, but where? Yeah. Initialize. Then just print hello. Oh. Hello. You can see LCD break line LCD print Taiwan. I hope this works. Taiwan, yeah. How many minutes I have? 8 minutes. Okay. In this way, we can write our own device driver incrementally with IRB. This is kind of cool experience, right? This is microcontroller programming. You don't need to write C. I wrote many C in behalf of you. So you should write only Ruby to handle hardware. And finally, we don't have enough time, so I will skip SPI class to use the thermometer. I will show you the final product of today. I copied app.rb. That looks like this. If /home/app.rb file exists, that file will run on the startup time. So just reset the microcontroller, start the application. You don't need the shell command anymore. Detach the cable and connect. Just connect the cable. Ooh. But it doesn't work. Sorry. I made another mistake. This should be broadcast. This is now battery driven. This is a standalone IoT product, right? And if I switch this on, oh. Hmm. The live demo is very difficult. Oh. I still miss something. No, this is broadcaster. Oh. Oh. Yes. This is now reporting the temperature of the room through BLE. And we have still time. Okay. Ah. I don't know why, but now observer device is working to catch the BLE radio wave from this device. And if I things go correct, this screen shows the temperature of this data. But now it doesn't work. I don't know why, but it should work. In this way, we can create BLE application, real BLE application with Ruby. What I wanted to talk about today is PicoRuby is a Ruby implementation targeting on one-chip microcontroller and built-in peripheral gems for general IOs, such as GPIO, I2C, SPI, UART, and ADC and PWM that I skipped today, but they are ready. And you can incrementally write your device drivers and applications with PicoIRB. And the BLE gem is also almost ready. It's kind of unstable, right? But almost ready for real applications. So you can make an IoT system with Ruby. So that's all for today. Please shoot this QR code and target that map at my repository, which is github.com PicoRuby/PicoRuby. Thank you all.
Okay. Thank you. Thank you, Hitoshi Hasumi. Thank you for your informative sharing. Now we have no time for Q&A session, but if you have anyone have questions, please raise your hand. Okay. Now let's end in this meeting. this meeting is ending. Then we gonna sharing something about. If you want to attend the official party, please raise your hand. Okay, about 80% of person. Okay, and then the official party will commence at 6 o'clock p.m. at the PicoRuby office. The topic of the panel discussion will be the path to engineer happiness in the age of AI. We welcome everyone to attend. And remember to bring your badge to attend official party. And again, please remember to check in at the reception tomorrow for getting a lunchbox. And if you find some lost items, please bring them to the reception. Thank you. This is room L405. We have come to the end of RubyConf Taiwan Day 1. Thank you for your participation.